think we can proceed to
Yeah.
our
Okay. Yeah, I think thank you, Mr. Alexander, for your presentation.
Okay, thank you very much.
Okay. Okay. We should go to the next one. The next presentation is on code IconSit 59 with paper ID 157070412 with title Recent Trends, Opportunities of Remote Multi-Parameter PMS Using IoT by Rajesh Suresh Nair, Juana Miriam Lawrence, Aparna Vyakaranam, Satya Devu uh, Syahim, Rafida Sulo, Nur Asnan, Muhammad Nur, and Ahmad Fairuzabadi Mansur. Okay, you can prepare your presentation and share your screen. I think there is Juana. Okay, Miss Juana.
Yeah, is my screen visible?
Yep,
And am I audible?
yep, you're
All
good.
right.
Okay, you have 20 minutes from now. Take your time.
All right. So good evening to the panel and to everyone present here. My name is Joanna Miriam Lawrence. I'm a final year student in Manipal International University, where I'm pursuing my degree in computer engineering. And today I will be presenting my paper on the recent trends and opportunities of a remote multi-parameter PMS or patient monitoring system using IoT. So in this presentation, I will cover the introduction where I'll briefly explain about a PMS and an RPMS. I will cover the problem statement, which led to us designing this proposed system, the previous works or literature review, the proposed system, and finally the conclusion. 1.4 million is the number of people who are in assisted living in healthcare facilities in the US. So the issue with these people who are living in these assisted healthcares is that they need constant monitoring, constant attention 24/7, so that when they are in need of any medical emergency, they can get the assistance that is required. So with an RPMS or a remote patient monitoring system, we can enable these people to live in the comfort of their homes while still getting the benefits of living in an assisted healthcare and at the same time reducing the cost instead of living in these facilities. So I'll start off by introducing what a PMS or a patient monitoring system is. So essentially, it's a collection of sensors and of software that is used to monitor a patient's vital signs. And this is usually present in hospitals and clinics. However, recently it's been looked into to implement remotely via IoT. So a remote patient monitoring system, or an RPMS, is essentially a PMS that is set up in a home environment or set up outside of a hospital environment, thereby being a remote patient monitoring system. So as I mentioned earlier, these are usually used in cases where the patients don't need to be constantly given their attention, but they need to be constantly monitored, such as patients who are recently discharged or have recently had a surgery. So the benefits of this is it allows detection of the illness in real time. It allows the patients to be constantly monitored. It prevents the patient's illness from getting worse. And most importantly, it reduces the cost of further hospitalization. So with an RPMS, the general structure or the way that it works is it is a collection of sensors that would collect data about a patient's vital signs, such as heart rate or blood pressure. And this data would be transmitted to a server, which would record and process this data. And finally, this data would be observed by a doctor, analyzed so that they can make the necessary recommendations or decisions on the patient's behalf or on the patient's condition. So $100,000 has been spent per annum for the maintenance and implementation of these remote patient monitoring systems. So One very obvious drawback is that this is a large amount of money. So our primary problem statement here is the expense involved with these systems. So with a conventional PMS system, where the patients are monitored in the hospital, they incur the overnight fees of staying in the hospital. Then there's the further transportation and accessibility issues that some of them might face. So when that's combated with an RPMS, there comes the issue of the patients needing to bear the cost of the RPMS as well, which, as we saw earlier, can get to be quite expensive. So therefore, this brings about the requirement for a low cost, but still a cost of but still an effective replacement to these high-level technologies. And thereby we propose our solution, which is a remote multi-parameter patient monitoring system that uses IoT and is based on the SVM, or support vector machine algorithm. So these are some of our previous works, which I will briefly go through. So in one such study, it took a look at an Arduino, which was being used as a sensor hub. So the Arduino was connected to the sensors connected to the patient, such as like the heartbeat sensor, temperature sensor. And this sensor data was transmitted to the user's device via GSM. So the limitation of this system is that it requires an active GSM connection rather than Wi-Fi to transmit data, and there's no interface to check readings or to host any live checkups. And in another similar study as well, we took a look at the use of an Arduino Uno with an Ethernet shield and with the Blink server. So here again, one limitation was that the interface could only monitor the patient, but it didn't provide any notification services or checkup services. And most importantly, the data transmission was wired because it was using an Ethernet, therefore making it less mobile, like greatly reducing the mobility. So that was another huge limitation in that project. And thereby we come to our proposed system, which is a remote multi-parameter patient monitoring system that aims to be low cost. It aims to use the support vector machine to determine the patient's condition by monitoring their stable state. And furthermore, it would provide notifications to the affiliated hospitals when the readings from the sensors are undesirable. And the interface also allows healthcare providers to access the records, and the video conferencing functionality that we plan to implement would allow the healthcare providers to conduct virtual remote checkups in cases of emergencies. So this monitoring component will be set up and connected to the home Wi-Fi of the patient, and the doctors can access the patient's biotelemetry or the patient's biosensor data through the web interface that would be accessible from their computers. So they'd be able to receive the notifications and the alerts through this very same interface in case the patient's condition becomes worse. So to just quickly summarize all the features of our intended system, one is real-time biotelemetry or biosensor data tracking. Another is it would be able to adapt to each patient because of the use of machine learning algorithms, which I will explain shortly. It would be able to alert the hospitals automatically when the reading is undesirable. And finally, it would have video conference support for online checkups remotely. So this is a diagram of our proposed work. So as you can see, the patient would be connected to an Arduino, which would act as the hub for the sensors. And these sensors would be connected to the patient and would be constantly monitoring the patient's vitals and the patient's biotelemetry, such as blood pressure, saline skin sweat levels, temperature, blood oxygen levels, ECG, and so on and so forth. So this sensor data would be sent to the Flask application, which would be hosted on our cloud web server. And this web server also would have the machine learning algorithms for it to do the ML processing. And in our case, using support vector machines. So the data would be pre-trained with localized data sets. And the sensor data would be the patient sensor data, would be compared against the normalized confidence values from the previously trained data. And if the patient's biotelemetry falls within this normalized threshold, then the patient would be in a normal condition. And this data would just be used to further refine the data set and to improve the algorithm. However, if the patient's biotelemetry is seen to fall outside of this threshold value, then it would essentially mean that the patient is not in a normal condition, or the patient's condition is undesirable, and thereby it would push a notification to through the notification system to inform the hospital or the healthcare professional about the patient's condition via their devices like a smartphone or a desktop. And furthermore, if you take a look at this image, the doctors and the patients as well would also be able to view the patient's medical records, as well as perform the online checkups that I mentioned earlier remotely using video conferencing. So one advantage of this system, especially, is because it aims to use machine learning. So with the support vector machine algorithm, it's ideal for binary classification, or like two-group classification, which in our case is desirable and undesirable. And thereby using this SVM algorithm, it would be able to further improve the accuracy of the system and further tailor the system towards the patient itself. So the advantages of our proposed system over the previous works are: it is cost effective, since it's only as expensive as its components. It can be implemented at home. It uses the SVM algorithm to adapt to the patient. It can monitor up to 5 parameters, which is ECG, blood pressure, oxygen, skin sweat levels, temperature, and it would be able to notify the hospital when the patient needs attention. And furthermore, it would also provide an interface for the doctors to view the patient's records and check up on the patients. So the components in our system would include the monitoring system, which would include the microcontroller, the Wi-Fi module, and the sensors, which, as I mentioned earlier, namely the ECG, blood pressure, pulse oximeter, and so on and so forth. The web server and the communication interface. So for our monitoring systems microcontroller, chose to use the Arduino Uno. So this would receive data from the connected sensors and transmit this data to the web server using the Node MCU Wi-Fi module. For the web server, we chose to use the Heroku Cloud Platform. So this would be used to host the programs and the scripts, and it would receive data from the monitoring system, process it using the machine learning algorithm, and perform binary classification. And furthermore, it would host the communication interface. Then finally, for our communication interface, we've chosen to use the Flask micro framework, which is a Python-based web micro framework. And this interface would essentially provide access to records and allow communication between the doctor and the patient. And it would furthermore allow regular checkups to be held remotely. So to conclude, patient monitoring systems are essential for the safe recovery of patients. Using a remote monitoring system could enable providing monitoring outside of the traditional PMS settings. Furthermore, it would help reduce deaths caused by negligence. So our proposed remote multi-parameter patient monitoring system aims to fulfill all of the above, and it also aims to provide a system that can be tailored towards each patient, that can reduce the travel and hospital costs and address the financial and accessibility concerns that several patients might be having who have completed treatment and need to be observed after treatment. And furthermore, it would be cost efficient to implement and to maintain. So that is the end of my presentation. Thank you all for your time and attention.
Okay, thank you for your presentation. Is there any question from the participant?
Okay.
Okay, Mr. Chuan.
Okay, only one question from me. While you said before you have used the pre-trained model, Yes.
Yeah, we plan to use.
Yeah. Okay. Is there any difficulty when you retrain your model or fine tune your model to adapt with the new data from the sensor, and how to handle the noise from the data acquisition from the sensor that you provide from the Arduino system?
Okay, so certainly there would be initial difficulties, as with all machine learning algorithms, as you mentioned, caused by noise. But our purpose for using these data sets, these localized data sets, are because people from like different ethnicities, they have different constitutions, different like acceptable concentrations of, for example, sweat and oxidation, blood oxidation levels. So I believe that using a localized data set and further adapting it towards the patient is still more effective despite the initial hiccups that might come along with it, rather than not using a data set, not using any sort of adaptive machine learning.
Okay. Okay. Thank you for your for answering my question. Okay. Maybe is there any question from other participant or the other authors? No. Okay. Thank you very much, Juana, for the great presentation and answering my question. Now we will proceed to other authors.
Actually, Juana is the last on the list, so
Yes.
we're
We will
going back to the first
first one.
of the list, which have not seen yet before. I'm going to call for paper ID 15707030711, 317, okay. Title Talent Management in Agile Software Development, the State of the Art by Taki Chavdani Kandumani, Amir Masmul, Mehdi Dasti, Sami Kos Rafi, Mona Najafi Sawiri,